another year, and that means another year of meteor showers. Tonight, I'm out at Annandale State Park to watch a meteor shower. Oh, there goes one now. I can't believe how bright it was, and I can see it over this bright video light. Time to turn out the lights, lie back, and enjoy the show. Hello and welcome to the program Sula's Big Adventures with me, Sula. This episode is all about meteor showers. Well, what is a meteor shower? Well, first I have to tell you what a meteor is. It's just a rock in space that enters the Earth's atmosphere, and the resistance of air on the rock makes it hot. And what we see as a shooting star or a meteor is just a streaking glow of hot air as the rock moves through the atmosphere. As the Earth makes its annual trip around the sun, it passes through the orbit of comets and asteroids. Comets have elongated orbits in the Kuiper Belt or the Oort cloud, as discussed in my video on comets. And as they approach the sun in their orbit, the sun heats up the comet, causing it to shed off ice and debris. And the comet dust and debris from when our solar system formed 4.6 billion years ago drifts through the solar system, and when those particles collide with the Earth's atmosphere and burn up, we may see the glow in the sky as a meteor. On any given night of stargazing, you might see one or two random meteors, but when the Earth passes through the dust and debris left over from the orbit of a comet or an asteroid, it's at these times that we have meteor showers. The glowing streaks we see in the sky during a meteor shower can appear anywhere in the sky, but if you trace their tail back, they all appear to emanate from the same spot in the sky. Meteor showers are named for the constellation from which the meteors emanate, or appear to emanate, and that's called the radiant. By the way, meteors by definition burn up in the atmosphere. If a hunk of space rock survives a trip through the atmosphere and hits the ground, it's called a meteorite. And meteorites exceed the scope of this presentation. But meteors do not hit the Earth, so no need to worry while watching a meteor shower. There are 8 major meteor showers that can be seen from the northern hemisphere, and 5 of which can be seen from the southern hemisphere. Meteor showers always appear at the same time each year as we pass through the remnants of various comets and asteroids. For example, the Lyrid meteor shower that peaks in April is one of the oldest known meteor showers, observed for 2,700 years, and it has its origins from the comet C1861 G1 Thatcher. The Lyrid meteor shower peaks around April 21st or 22nd every year, and the radiant for the Lyrid meteor shower is the constellation Lyra the Harp. And they produce about 18 meteors per hour, although the Lyrids don't produce as many meteors as some other meteor showers. They're known for producing fast, bright meteors that leave glowing dust trails behind them, observable for several seconds. Lyrids appear to radiate in particular from the star Vega. That's actually pronounced Vega, but no one says that that I know of. But Vega, or Vega, is the brightest star in the constellation Lyra the Harp, and it's the star that Jodie Foster visited in the movie Contact when she came in contact with an alien civilization.
Position? I checked interferometry somewhere in Lyra, I think.
Vega? But when viewing the Lyrids, it's best not to stare at Lyra the Harp, because those meteors close to the radiant will appear shorter due to an effect known as foreshortening. And this is true of all meteor showers. There are 8 major meteor showers that I will be covering in this presentation. There are 2 minor meteor showers, the southern and northern torids, that only produce about 5 meteors per hour, that I'm not going to cover because that's too few. And last year, or 2022, Astronomers were predicting a possible new meteor shower that they were going to call the Hercules. That was a major disappointment, and having heard nothing further about it this year, I will not be covering that either. The first major meteor shower of the year is the quadrantid meteor shower, peaking on January 2nd or 3rd. You can find the actual date that they peak any meteor shower for the year you'll be observing by checking a meteor shower guide or wherever you get your celestial news. The quadrantids produce about 60 meteors per hour, and its origin is 2003 EH1, which is either an asteroid or maybe a rock comet, according to NASA. And the radiant is the constellation Boötes, but it's still called quadrantid because it was originally named for a constellation, Quadrans Muralis, named by French astronomer Jerome Lalande, and near the constellation Boötes, but it did not make the IAU list of the 88 official constellations. The quadrantids can produce a lot of meteors, but the peak is very short due to the thin stream of particles and because the Earth passes through those particles at a perpendicular angle. But they're known to produce a lot of fireballs. Fireballs are extremely bright meteors from larger particles. Fireballs are brighter than magnitude -4. In other words, brighter than the planet Venus. In April, we have the Lyrid meteor shower that I mentioned earlier, peaking April 21st or 22nd from comet C 1861 G1 Thatcher, and it produces about 18 meteors per hour and emanates from Lyra the Harp. In May, we have the Eta Aquarid meteor shower, peaking on May 4th or 5th, but active from April 15th through May 27th, and it comes from debris left over from the famous comet 1P Halley. Comet Halley is probably the most famous comet ever. It was probably discovered by Chinese astronomers in 240 BC, maybe even earlier by ancient Greeks, but named for Edmund Halley because in 1705 he predicted the comet's orbit and correctly predicted that it would return in 1758. Comet Halley takes 76 years to orbit the sun, and it was last seen in 1986 when it was a real disappointment. But Comet Halley won't return again until 2061. I'll probably be dead. Halley's been seen for millennia, and it's even depicted on the Bayeux Tapestry, which also chronicles the Battle of Hastings in 1066. The meteors radiate from the constellation Aquarius. It produces about 10 to 30 meteors per hour. The Eta Aquaria meteors are known for being very fast, about 148,000 miles per hour or 66 kilometers per second, leaving glowing, colorful trails lasting several seconds. They're visible in the southern hemisphere, where you're more likely to see more meteors, maybe only 10 per hour in the northern hemisphere. And that's because the Aquarius is low on the horizon in the northern hemisphere. And by the way, the constellation that is the radiant is merely a guide, and it has nothing to do with the source of the meteors. In July, we have the South Delta Aquarid meteor shower. It peaks about July 27th through 29th, and it produces 10 to 20 meteors per hour, visible from both hemispheres, but best seen in the southern hemisphere. They are not very bright, and you will not see anything at all if the moon is out. You can see the meteors from the South Delta Aquarid meteor shower into August, and they will be radiating from the constellation Aquarius in the southern part of the sky. The comet or origin for this meteor shower is unknown, but thought to be 96P Machols. I guess they weren't interested in watching the meteor shower. In August, we have the famous Perseid meteor shower, active from July to September, but peaking August 11th through 13th and producing wildly various amounts of meteors per hour. Do not believe what you see on the internet regarding prognostications of meteors per hour when it comes to this famous meteor shower. The Perseid meteor shower can produce up to 100 per hour, but normally 30 to 70 per hour. They're known to produce a lot of swift, bright meteors and the most fireballs of any meteor shower that we have. The Perseid meteors come from comet 109P Swift-Tuttle, which takes 133 years to orbit the Sun. It was last seen in 1992. It won't reach perihelion again until 2125. The comet was discovered by Lewis Swift and Horace Tuttle in 1862. It's a large comet with a 16-mile nucleus, twice the size of the object that hit the Earth, exterminating the dinosaurs. Giovanni Schiaparelli realized in 1865 that this comet was the source of the Perseid meteor shower. The radiant for the meteor shower is the constellation Perseus, the hero. And if you'd like to learn more about the constellations, here's a link to my video about the constellations of autumn. And I'll also put it in the description below because I realized recently that you can't see this description from the TV. Every October we have the Orionids. They peak October 20th or 21st and they produce about 10 to 30 meteors per hour. They're also from debris left over from Comet 1P Halley, which was named in Edmund Halley's honor because he realized that 3 previous comet sightings were all the same comet and that it would return in 17 something, but sadly it returned after he had died. The Orionid meteors are about 41 miles per second, fast meteors leaving glowing, colorful trails that can become fireballs. The meteor shower is viewable from both hemispheres. The radiant is the famous constellation Orion the Hunter, and many of the meteors appear to emanate from the bright star Betelgeuse. And you know what would be awesome and a great reward for living a wholesome life would be to be watching the Orionid meteor shower and have Betelgeuse explode in a supernova. No, better yet, a meteor shower that turned into a meteor storm and Betelgeuse exploded. No, even better. You know what would be even better reward for living a wholesome life? Watching the Orionid meteor shower turn into a meteor storm and Betelgeuse and Rigel simultaneously explode into supernovae. Back to reality. Every November we have the Leonid meteor shower, which peaks around November 16th or 17th, though active from November 3rd through December 2nd. The Leonid meteor shower produces about 15 meteors per hour, and the meteor velocity is about 44 miles per second. The Leonids have been known to produce tremendous meteor storms in the past. There was a Leonid storm in 1966 that rained down thousands of meteors. There was another Leonid meteor storm in 1998. Last meteor storm was 2001, but scientists can now predict the models of meteor streams and regions of density, and unfortunately the next Leonid storm won't be until 2099, and I will definitely be dead. However, I do consider myself lucky that I witnessed the Leonid meteor storm of 2001, although right in the middle of it, a thick bank of tule fog closed in on me, causing me to nearly die driving home on Interstate 5.
Oh God, get me out of here. I can't see a thing. Ah.
The source of it is Temple Tuttle, and it circles the Earth every 33 years. It won't be back till 2099. A meteor storm, according to NASA, is one having 1,000 meteors per hour, but I've never heard that definition before. But the Leonids have not produced anything great in the last 2 years. It was washed out 2 years ago, and last year I stayed up all night and only saw 2, but it does produce a lot of fireballs. The radiant is Leo the Lion. And lastly are the Geminids, which are believed to be the most reliable and best meteor shower, but also a cold, rainy time of year. The Geminid meteor shower peaks December 13th or 14th, but is active from November 19th through December 24th. It produces about 80 meteors per hour, and they're bright and fast at 22 miles per second. They can be seen around the globe and start, according to NASA, around 10 p.m. The source for the Geminids, unlike other meteor showers, is 3200 Phaethon, an asteroid, or maybe a dead comet, or what NASA calls a rock comet. 3200 Phaethon has highly elliptical orbit around the sun. When it gets near the sun, it does not develop a typical comet tail, but appears more like a rocky asteroid. The bits and pieces that break off are denser than comet flakes. 3200 Phaethon was discovered in 1983 by an infrared satellite and named Phaethon for its close approach to the sun for the Greek myth involving Phaethon, who drove Helios's chariot. The asteroid is small, it's only 3 miles across. The radiant for the meteor shower is Gemini, the twins. To view a meteor shower, you don't need any special equipment. You don't need anything at all. All you need is to find very dark skies away from city lights with a wide open view of the sky, or as much as possible. Dark skies are the key to seeing the most meteors possible. And if the moon is out, it'll wash out most of the meteors, no matter what you may see or hear in the media or on the internet. If you have a reclining chair, that's helpful. Otherwise, just lie on your back on the ground or on a tarp and wear warm clothes and warm shoes and take a warm drink. Lie facing the radiant, but don't look directly at the radiant because of the effect of foreshortening, which makes the meteors close to the radiant appear shorter. Stay awake and be patient. You aren't going to see a meteor every minute. That is unrealistic and it will cause disappointment. Another important factor to maximizing the number of meteors that you might see in a meteor shower is to observe after midnight, for most of them, often well into the early morning hours before dawn. If you keep looking up and you go out on a moonless night in a truly dark place, away from city lights, you'll see meteors more than the 1 or 2 random ones you might see on any given night. And you just might, if you've been living a wholesome life, see a fireball, or better yet, a bolide, which is a fireball that explodes in the sky. Or maybe you'll just see a lot more meteors than you have ever seen. Or maybe a very colorful long one that dazzles the eyes and stays in your memory. Have reasonable expectations and do not fall into the trap of listening to exaggerated media reports or things you may hear on the internet about the number of meteors per hour. Especially disregard any statements which refer to the ZHR or the zenith hourly rate. That is an absurd overstatement of the number of meteors that you might see. And most of all, have fun and enjoy the night sky. That's it for now. I'll see you soon. Dark skies forever. Sula, signing off.